Hi guys, Shouvik here. Welcome back to YouTube channel. So today we'll solve another question from Leetcode itself. So let's get started. Yes, so today we have these problems finding pairs with certain sums. So this question tagged as a medium and I feel so it's a very good problems to solve and it's like a very good problems on interview perspective to be going to be asked to a particular candidate and you like there is a high probability you are going to face these problems like if interviewer is kind of a uh, in line with object oriented programming principles, if they want to check, then this is indeed a good problems to you are going to face on an interview. So yeah, so we can just quickly start on the first problem statement understanding and followed by intuitions building we do for sure, and post that the code iterations, and after that the time and space complexity analysis we will do. Yeah, so that is the agenda that we have followed generally, and we will follow the same for this. Yeah, so what we have given, so they have given two integer array nums1 and nums2, and you are asked to implement a data structure that supports queries of two types. Okay, so we have to support two types of queries. So which are those? So first one, add a positive integers to an elements of a given index of nums2. So we should have to add a positive integers whatever it is given to you in the add query. We have to add that positive integers to nums2 of the provided index. So we will see, like, just first understand the problem statement, then we will see with the example test case. You will definitely get the gist. Then we have the count the number of pairs ij such that nums1 of I plus nums2 of j equals to the given value. So that value is given to you in the count of functions parameters altogether, right? So here you can see, so our I should be, ith index should be in the boundary of 0 to nums of length, and j in the range of 0 to nums2 of length, right? So now what we have to implement the find sums pair class. So this class we have to implement. So initially they will giving you the empty constructor, they will give you the add functions, they will give you, and the count functions they will give you. You have to fulfill the functions with the corresponding implementations. So now in find some pairs, they will give you the nums1 and nums2 altogether. They will give you nums1 and nums2 altogether to basically store, or based on that you can initialize your data structure, right? So this 2 is given to you. Then they have given a void return type add functions. The first parameters is the index and the second parameters is val. So what we have to do in add functions, at nums2 of index, whatever the index value is given to us, nums2 ka index pe on nums2's index, we have to add ons whatever the value present already in nums2 of index, we have to add ons plus equals to val, as simple as that. The second functions is int count, and the tot is given to you. So tot means total. So we have to return the number of pairs of ij. So I we have to select in nums1. What are the values of I? I should be 0 to nums1 of length. Within the boundary we can select any index and nums1 of I, and similarly j we have to select from nums2, and their summations should be equals to tot, right? Should be equals to the tot value is given to us, right? The problem is, I guess, is very straightforward, very simple. If you just with proper intentions read every line by line, you will definitely get the gist in the very first way. But yeah, let's go with the example test case understanding also. So here you can see, find some pairs. They have giving you nums1. This is the entire nums1 they have given to you, and nums2 they have given to us. So that is find some pairs. That is of the first constructor call, the first constructor initializations. These things is given to you. Then we have this. Count things. So count means count of 7. So that means how many indexes of nums1 of I plus nums2 of, how many indexes in j of nums2, such that nums1 of I plus nums2 of j is going to give you 7. So there are 8 indexes. So now let's understand that. So first, new find some pairs. This nums1 and nums2 is given to you. Then find some pairs, whatever the object they have built. So I guess you guys should know object oriented programming. The init method or the constructor in Pythons is going to take the constructor initialization. So nums1 and nums2 is going to be get on the very first constructor initialization. So on the constructor initialization, they have given you nums1 and nums2. Now with the object that we have created with the constructor, that object we are going to call our count functions with 7. So this count function should return me how many pair of nums1 of I plus nums2 of j is going to give me equals to 8. So there are, sorry, is going to give me 7. The summation is 7, should be 7. So here you can see how many pairs, there are 8 pairs. Whom are those? 2 2, 3 2, 4 2, 2 4, 3 4, 4 4. So make 2 plus 5 pairs of 5 1 and 5 5, make 3 plus 4, right? So that many pairs we can do, we can build. If you're not able to understand, so here you can see that second index of first nums1, second index of nums2, 0 1 2. So whatever the value is 2. 0 1 2, what is the value of nums2 is 2. So 5 plus 2, you are going to get 7. So we have identified how many 7s, right? So these 2 and this 5 can be a pair, these 2 and this 5 can be a pair, these 2 and this 5 can be a pair. So constanting this 5 as a constant index of nums2. On nums1 we have 3 indexes, 2 2, 3 2, 4 2, correct. So we have total of 3 indexes. Now these 2, 0 1, sorry, not these 2, 0 1 2, right? 0 1 2. So this we have done. So this 2, sorry, this 5 is going to pair with this 2, this 2, this 2. So 2 2, 3 2, 4 2, right? This 5 is going to do the pairing, right? Then 0 1 2, this 2 is going to pair with the 4th index. Who is the 4th index? 0 1 2 3 4, this 5. So 2 4 is the another pair, right? 2 4 is the another pair. Now we have 3 4, because now what is going to be happen? This 5 is going to be constant and we have this all the indexes that we just saw. So for this 5 we got all these 3 indexes. So 2 2, 3 2, 4 2. Now constanting this 5 index, so that is of 4th index of nums2, we have 2 4, 3 4, 4 4, right? So how many we got? We got total of 1 2 3 4 5 6, total 6, right? Then next to is what? Then 2 5, 2 plus 5, okay, that we understood. And pairs 5 1. Now there are how many pairs we got here? Here we got 6 pairs, but the answer is 2. So there are 2 more pairs. Which are those? 0 1 2 3 4 5. This 5, 5th index is 3. So these 3 can pair with this 4 and this 4, right? So that means 5 1 5 5. So 5 1 5 5. That makes you 3 plus 4 is 7. So total how many pairs? Total of 8 pairs. So I think that exactly you have to understand how actually we are calculate the pairs altogether. And add functions is very simple. So our on nums2's 3rd index, please add whatever the values plus equals to 2. So 1 4 5 4, 0 1 2 3. So this index is targeted. So on targeted index we have to do plus 2, whatever the previous value, 0 1 2 3 4. So 2, so 2 plus 2 becomes 4. So here you can see it's highlighted all together. So this becomes 4 now. From 2 it becomes 4 now. So similarly other operations you can calculate. You can just go with this, and similar calculations they have did for count calls and the add calls, the count calls and the add calls. Yes guys, so I think the problems now is bound to be understandable by all of you, but if not, I will highly encourage to just rewind the particular portions of the video and you will definitely get the gist. Now we'll just do a quick constraint walkthrough so that we can understand what actually a big of n or n log n or big of n square, which solutions is going to give us an AC for this particular problem. So that we will going to understand just by the iterations of the constraint. So let's quickly do that. So nums1's size is very small. Okay, the point to note, it's 1000 only. Nums2 size is a little bit big. So that is of 10 raised to the power 5. Nums1 size, nums1 of I is high, 10 raised to the power 9. Nums2's of I, it's also kind of high only, 10 raised to the power 5. And indexes that we know, that is of 0 to nums2 of length. The index value of the functions call we will get. That's fine. That there is no hints we are getting. And val is a very high value of 10 raised to the power 5, and tot is the very high value 10 raised to the power 9. And now the point, how many add or count calls you are going to make? So there are at most thousands calls are made to add and count each. So that is the second point. Right? So what is the so that this thing is going to be constant. That is not in our hand. So there are at max 1000 calls is going to be triggered to our add or count functions. So our add or count functions, whatever the calculations we are doing, it's straightforward going to multiply it with 1000, because there is a 1000 invocations within 1 second time frame is going to eligible to the constant we are saying. So within the add or count functions, whatever the logic we are going to write, it should going to execute within the time frame of 10 raised to the power 5, because what is the allowed operations we can do in 1 second. So if we can quickly go to our OneNote now. So now actually we have to understand. So what are the things is given to you. So from the constant we will build our algo. So see how from the constant we can get some hint to think on a particular direction. So all the constants is kind of a very high limit. So which one is the lowest? Can we play the game with that? So okay, it start giving me, make myself crying mostly. Are you allowing me to write? Nope, it is not very good. Now yes, I can write. So add or count, whatever the functions calls, they are allowed to make. So there is a 1000 calls they can make for sure. So within the count or within the add functions, whatever the operations we are allowed to perform, it should execute in 10 raised to the power 5. So that 10 raised to the power 5 into 1000 calls here is going to give you 10 raised to the power 5 into 10 cube. So which is inside or equals to in the range of 10 raised to the power 8. So it's kind of, your algo is going to be cried out at very high test cases, but at last mostly it is going to give you an AC, but I'm not sure on that. But so I know my nums1, they are giving the size of the nums1 is kind of a little small here, so they are stating it is within the range of 1 to 10 cube. So what is the second observation? So this 10 cube factors so is kind of a constant, so that is not in our hands, that is the test cases hand, but this things is in our hand. Can we play the games inside our nums1 or nums2, whatever the functions, in our add or in the count, whatever the functions, can we do the operations to only the nums1 ka size? Can we do the games within the nums1 ka size, so that if we are doing the job inside count or add functions with nums1 of size, then it is as big as 10 cube, and the maximum functions call are allowed to be 10 cube. So it is bound to be never exceeded our boundary of 10 raised to the power 8. It is never. So it is going to give you a for sure short accepted. So that is one observation. Now okay Shouvik, I am fine with this. Now tell me what actually we can do. The add functions is very simple. Add functions, there is nothing. So let's try to build what is the brute we can think. So there is a constructor we have named as init, and it is going to get two value. One is nums1, another one is nums2. So we can, how we should assign them? We should assign, as it is an object oriented programming, we have to assign them inside a class level variables. Inside a which variables? Class level variables, so that it is going to be used in other child functions. Otherwise you are not going to access those. You have to define those in the class level variables. So on Java you should be aware of this. So this dot a equals to a, this dot b equals to b, like this you have initialized. On Python similar with self. Rather than this, we are going to use the self keyword. Self of nums1, so which is a list, we can assign the nums1. Self dot nums2, you can assign my nums2. You can assign the nums2, right? That you can do. Okay, very good. Now there are two functions. So the add, let's done the job, which is the easiest one. On add, do you guys see we have to use our brain powers at all? Do we have to use? No, it's very straightforward. So what we can do, self of nums2s of index, whatever the value, we can do plus equals to val, right? We can do. Now the count function, that's it. So which is big of 1. So add functions we are able to implement in big of 1. Now there are count functions. So on count functions, it is going to take a dot, right? It is going to take a dot and we have to return an int of this. How many I and j, distinct I and j, which are summed by to give us dot. So now what actually we can do? So we know there are at max 1000 calls. So everything we have to do inside this in the range of 10 cube. So now let's try to build an intuition. So let's suppose I have an array. So what we have now with in the hand. So you have this array, let's suppose A, B, C, D, and let's suppose you have this array X, Y, Z, P, Q, R. So that is my, let's suppose, nums2, right? So these two array you have to you have in your hand. So now I know its maximum size can be as big as 10 cube, and this maximum size can be big as 10 raised to the power 5, right? So and this functions call here, the functions call allowed is 10 cube. So and we have decided we will do our entire job on this nums1. We will do our entire jobs in nums1 only, right? We'll do our entire jobs in nums1. So now we have to find how many nums1 of I can pair with nums2 of j such that nums1 of I plus nums2 of j is giving you dot. So what I can do, I can initialize my answer equals to 0. Let's try with a brute first. For each in nums1, we will iterate only on nums1, not nums2, right? Otherwise it's the kind of trying accepted maybe we are going to get. But in iterations of nums1, it's for sure accepted. It's a sure accepted. Now for each in nums1, now what is the rest part? Is nothing but dot minus rest. Sorry, dot minus each. So that is the rest. So we have to need a total of dot and we have each. So what is the rest part? Is dot minus each. So this rest, where we have to find it? In nums2. So that means in nums2, how many rest are there? All the rest can pair with my each. Yes. So now if I am going to start a for loop for let's suppose p in nums2. Now if I'm going to do if p equals to rest, then I'm going to increase my answer plus, then this is going to give us a TLE. So we can't do this. So in constant time, you have to say me how many occurrences of rest in my nums2, right? So this we can't do. So now we definitely need a frequency of that of every characters, so that on which in nums1 or nums2? In nums2. So I need the frequency of every characters in nums2, so that I can say my answer plus equals to, so let's suppose I am going to store them in a default dict, so that I can directly call my default dict of rest, and it is giving me how many rest are present in my nums2. Yes. That's it. And finally I can return my answer. Now where then we can create this dictionary. In count, nope, because there are 1000 calls already. We can't do iterations to create the dictionary here. In add functions, nope. Then where? In constructor, because constructor is going to be initialized at once. There is a single call is going to make to your constructor. So on constructor is the ideal place, because these functions can be invoked with the same object with 10 cube times. These functions can be invoked with the same object at 10 cube time. So but the constructor is the only functions which will be going to invoke with a single time. So we can create our dictionary that is of dictionary with my nums2 in constructor. So I can create a self of dd, that is I can initialize with my default dict, and now I can iterate for each in nums2, and I can do self of dd of each plus equals to 1. So I have stored everyone's frequency that is there in my bucket, and now on this count functions I can directly call my self dot dd of rest, and I can store that frequency. Yes guys, and that is, we have just going to the root and we are able to get a fully accepted solutions for this particular problems. So yes guys, that's all about this particular video solutions. And now we can quickly do the code iterations. There are few more optimizations which I will going to explain on the code iterations part, but this algo which we just built is giving you a for sure accepted. So now I have, I guess, few submissions I did. So the first ones that I did is this one. So this one is exactly same that I have just explained to you guys. So here you can see, like I have initialized my self of nums1 to be nums1, self of nums2 to be nums2, self of dd equals to default it, and I have create for each in nums2 self of dd equals to each plus equals to 1. And I have did for add, what we have to do, present values. So now we have dictionary, right? So now on add function there is a slight trick that we can just do on the code iterations only. So now on the present value, so now when on the add functions call, as we are maintaining a dictionary, so that means we have to update our dictionary also on the add functions call. So there is a little more task we have to do. So whatever the present value in my self of nums2 of index, we can store in the present value. The new value is nothing but the present value plus val. So that is we are doing for plus equals to val, we will do on that particular index, and self of dd of present value, that is going to be omitted out of its single occurrence, so minus equals to 1, and self of dd of new value is going to be add plus equals to 1. And now self of nums2 of index, we are going to store the new value. New value is nothing but present value plus val. Now count functions is exactly same that we discussed. Answer equals to 0 for each in self of nums1, that is the smallest one, and answer plus equals to self of dd, that means on my dictionary that we built with nums2, how many rest is nothing but my tot minus each, how many count of that we are going to store to my answer with the incrementation, and finally we are returning my answer. Yes, it is bound to give you a AC for sure. Now there is a very slight optimizations you can put. Now if you are going to sort it, now I know we have to iterate for our nums1 only, and within the nums1 only, do we need to iterate all of them? So what I am stating, so let's suppose on the example test case itself, so let's suppose I have 2 2 2 and I have here 5 5, and the target and the tot they are looking for is 7, right? So what we are doing, we are iterating to my nums1 to basically, so here I have dictionarized it, so that means dd of 5 it is storing as 2, dd of 5 it is storing as 2. So what we are doing, so we are basically doing this 2, how many count for this 2, there are this and this. So we are going to iterate for each in nums1, and for every 2 we are going to increase our answer plus equals to 2 for this again plus 2, this again plus 2, right? So this is going to be plus 2, then again answer plus equals to 2, that is just iteration, So how many we got finally? 2 3 4 5 6, so we got 6. Can we do rather than iterating all together to all the occurrences of the same numbers in nums1, can we do a little more optimizations? Can we dictionarize our nums1 also? Can we dictionarize our nums1 also? Yes. So if we dictionarized it, so we have 2's occurrence is 3. I am going to name it as dd1, and on dd2 I have 5 co-occurrence as 2 times. Now what is the answer? So this 2 has 3 occurrences, so 3 occurrences can be going to connect with these 2 pairs with how many ways? In 3 cross 2. So this 3, this 2, this multiplications way. So that is you are going to get it directly 6. Yes. So this optimizations we can do for sure rather than, but yeah, the time complexity is going to be same. When my nums1 has all the elements as distinct, then the time complexity is again 10 cube only. If nums1 is size is also 10 cube, then it is again going to be a 10 cube only. But if there are repetitive elements in nums1, then that is an optimizations for sure we can incorporate, right? So okay, Shouvik, we understood. We can do dictionarized to both, right? That is one observation. You are very correct. We can do a slight optimizations to my time complexity when my nums1 has repetitive elements. But your first approach is very straightforward, very simple, which is also giving you a full accepted. But we are trying to do some more more optimizations. Maybe interviewer asked you, can you do some more optimizations on time complexity part? Can you do? So that's the reason. So always guys, please be prepared for the follow-ups. Please try to solve a problems to its maximized optimized versions. Why I am stating? Because currently job market is highly competitive, and if you are not on the beyond the bar, then someone is going to get the opportunity that you can also grab. So that's the reason you have to do your best to best, whatever that logic, whatever the intuitions is coming to your brains, which actually make a single liner optimizations also, please explicitly state to your intent. So that's the reason we already got an accepted submissions, right? But still now I am explaining that's the because of that, so that you can think on multiple approaches, multiple alternative approaches you can give to your interviewer. After going to get an accepted, you are not stopping, you are still giving optimizations to your problem. So that's actually making yourself different from the other candidates, no? So that is one optimization for sure. Now let's suppose one more things. Let's suppose we have this 2 2 2, and then let's suppose we have this 9 9, right? And then we have, let's suppose here this 5 5. So this let's suppose my nums1, and let's suppose this is my nums2, and the tot is same only. So by this Shouvik, we did a things that is 2's count is 3 times, 9's count is 2 times, and here 5 count is 2 times. So when we are going to iterate on my this dictionary, right? So I can name this as dd1, and that is my dd2. So we are going to iterate on my dd1s of keys, right? Now when I am going to see this 2, I am going to search for this 5, and I got this 2 occurrences. So I multiplied this and this. So I got an answer of 6. Now when I am at 9, when my key is 9, so which is more than my total, which is greater than my total altogether. Do you feel, guys, for this we are going to get any pair of dd2, because it itself is more than my total. The summation should be equals to 7, right? But we got one element which is itself is higher. Then is it going to help a lot? Then is it going to help at all? Nope. You are not going to search at all for this kind of pairs. So now let's suppose after that you are going to again get a 5, and on this let's suppose there are 3 occurrences of 2's. So then this is again going to get a paired with let's suppose 5 occurrences is 1 time only. So this 1 is going to multiply with this 3, and it is going to get a +3 to your answer, right? But okay, so some elements can be higher of my total itself, which is not going to get my pair, but after that some elements may be smaller. So now what we can do, if we can sort the dictionary altogether in perspective of keys. So if it is of kind of 2 5 9 11 15, so if that is my dd1, so 2's we are getting pairs, 5 we are getting pairs, but when we are at 9, it's altogether is higher. On right part checking of the keys is pending to my dd1s. Do we need to check them? Nope. It's completely useless. Because my current keys is altogether higher, and we sort them in the order of the keys, right? So for 9 is altogether going to be higher my total. Then on the right checking is not needed. Right checking is extremely not needed, right? So that is the two optimizations that we discussed. We can incorporate to get a fully optimized time complexity for this particular problem. So now let's just quickly do the code iterations of the very latest optimized submissions that I did. So let's focus on this at very last. So you can see it's of 100% faster. So that is obviously a beauty on this particular submission. So I have initialized myself of nums2 to be nums2. Now nums1 I don't need, because I will play my games to dd1s. So I will dictionarize my nums1 also, and if I am going to dictionarize my nums1 also, I don't need nums1 altogether to be stored in any other variable. So I have self of dd1s, I have stored of nums1s ka counter. So these counter functions you can read on Python website or in Googling. So that is basically giving you a default dict altogether by doing the single iterations only. And counter of nums2, that is of dd2. We have now defined our dictionary in kind of a different format, but it is of big of n to initialize our dictionary for sure. The same things that we do for each in nums1, dd of this each plus equals to 1. It is doing the same things in internally. So we have used the counterflows. Now we decide we'll sort them. We will define a key size. We will iterate to our keys list, and keys list should be sorted of dd's keys, dd1s of keys. It should be sorted of dd1s of keys that we just discussed. So how we can build it? Sorted of self of dd1 of keys. So we have stored in self of keys. Now we will iterate on this only. Yes, we will do. On add functions, what is remaining? Self of dd2 of self of nums2. So nums2 of index. So self of dd2, whatever the value present in self of nums2's index, we are going to decrease its count to be minus equals to 1. So that means this element is going to be, this element's count is reduced by -1 to my dd2. Then I have increased my self of nums2 of index plus equals to val. Then on self of dd2 of self of nums2 of index, whatever the updated value of self of nums2, so that element's count should increase plus equals to 1 in my dd2. So we did it. All the things in big of 1. All the things in big of 1 only. Right. Now on the count functions, count we have initialized to be answer equals to 0. And now on which list we are going to iterate? In self of keys, which is sorted itself and dictionarized. Dictionarized nums1 with sorted. Dictionarized nums1 with sorting. So we are iterating for each in self of keys. Now if each altogether higher my total, do we need to check on right? Do we need to check in any of my rights altogether then? Nope. Directly print. Otherwise, I will check if my tot minus each. So this should be present in my self of dd2, right? If it is present, then answer plus equals to self of dd1 of each. And on dd2, we are looking for tot minus each. How many count of tot minus each? So self of dd2 of tot minus each. We are doing the multiplication of these two, and I am increasing my answer with the value that we are getting after multiplication, and finally we are returning the answer. So this is going to be the, I agree, it is going to also do a big of n iterations for sure. So when every elements of my nums2 are distinct, I am totally agreeing. It is kind of a same time complexity, but it is a little bit faster when as we are doing dictionarized, so that if nums1 has some repeated elements, we are not going to iterate to all of it. So because we have dictionarized my dd nums1, we have dictionarized my nums1 to dd1, right? And then as little more optimizations we did by sorting them in the order of keys, so that when we just get a key which is more than my total, no meaning to check off its right. Till now I got my answer. No meanings to check off its right. Break it. Yes, so this you can see it's the 100% faster solutions of all the submissions over the Leetcode. So now we can quickly discuss the time complexity. I am going to discuss the time complexity in kind of big only. So the time complexity here you can see it's this init functions is going to be a call on single time. So I am not going to go to the every line by line time complexity on, because it's kind of a like not actually this object oriented principles generally interviewer focus. The bigger level time complexity you can give only. So this add functions is big of 1 for sure. This init functions is going to be called at one time only. So this all the things is kind of a big of n or big of n log n, where n can be as big as 1000 only. So I'm not going to consider this. This count functions is actually going to take the main time. So how many invocations of maximum invocations can be possible of my count? That is of 10 cube. Into at very worst case, how many self of keys we are going to incorporate? We are going to iterate. So we are going to iterate. If all are distinct, then we have to iterate to all of them, and all are within my total. Then that is the very worst case. On that case, the time complexity is bound to be big of 10 cube plus 10 cube. So that is of big of 10 raised to the power 6 at very worst case. And on space complexity, we are using 2 dd1 dd2. I can say it's a big of n plus n, 2n, n plus m I have to say, and keys is kind of a m only. So it is kind of a, I can write, if I can say my nums1 is n in terms of n size, then n plus n, 2n, and dd2 of m only, and I am using this nums2 also. So it is kind of a big of 2n plus 2m, right? So that is the space complexity. Now can Leetcode predict my time complexity? Please do, please do. Hey Leetcode, can you help me with your time complexity analysis? Server busy kya? Okay, server busy. Let's retry. Now also busy kya server? Oh shit. Their server are useless servers. It's always becomes busy. Space complexity. Can you predict, man? Or server busy. Last try. On time. Okay, so I am going to get a server busy for again. So yes, guys, I am not going to check on the server. And because we are pretty confident, because that is the most worst to worst case time can be go, which is like very small out of 10 raised to the power 8 altogether, right. So you are going to get a for sure shot accepted, because you can see it's a kind of a most optimized times you can achieve. Yes, guys, so this all about this particular video, and on interview perspective, I will highly encourage to practice to you guys. Please submit the entire problems on your own. If you understand the entire video, it's good, but after that, please do a self submission, so that you are not going to forget any of the things that we have done to this particular video. So do at least one submissions, and if you guys are able to understand the entire explanations, the entire whiteboarding we did, entire time and space complexity, line by line iterations, code iterations we did, then please do subscribe to it, and please share the videos to your friends circle who are also preparing for top product based company and brushing up their DSS skills. And please turn on the notifications, so that when we are going to live to our next video, you guys are going to get the notification as soon as possible. So that's it, guys. That's it for today. Let's meet with another day with another beautiful question. Bye, guys. Bye.